Here's another video for my A-level electronics students. Previously I explained about my initialization routine where I was configuring outputs and inputs on port B. So I would do that via TRISP, tri-state register. And in this video I'm going to make use of that. I'm actually going to pulse one of these outputs high and low, and then I'm going to repeat that 10 times. So I've made myself a subroutine here. I've called it pulse 10. So pulse 10 is actually a label, but you'll notice that we've got a return on it. So when I call it, so I'm going to just uncomment this line here. When I call pulse 10, it goes to that label and then it returns. And so that's all of my subroutine now. Notice this is a point for my students, maybe other people as well. I like to have a comment with a load of lines in between each of the subroutines because it's easy to see that is a block of a subroutine there. And so let's have a look at the pulse 10 subroutine. Well, if we just jump into the middle bit here, you can see that I'm going to turn one bit, which is RB4 high, because I'm going to set it, and then I'm going to bit clear file, so I'm going to clear it. So I'm just setting it high and low. I've not got any delay in it, so it's just going to set it high and then low. It's only going to be high for, well, in this case it's going to be 1 microsecond if I've got an external oscillator at 4 megahertz. And so it's going to do that hopefully 10 times. So how does it do it 10 times? Let's have a quick look. First of all, because I'm going to be working with port B, I need to make sure that I'm in bank 0, and to do that I'm going to clear the status bit RP0, so bit clear file. So of the file status, clear the bit RP0, so that takes me back into bank 0, which is where port B is. Then I want to do things 10 times over, so I'm going to move the literal value of decimal 10 into the working file register, and then I'm going to move the working register into the file counter. Now let's just see what counter is. Counter is just and it equates to the number hexadecimal 10, and the number hexadecimal 10 is going to be there. If you look over down there where the mouse pointer is, so that's where I'm going to store the counter value. And then what I'm going to do, sorry, excuse me. So then what I'm going to do, I'm going to repeatedly do this. So I'm going to set the bit. I'm then going to, set the bit. Then I'm going to clear the bit, and then I'm going to decrement file and skip if 0. So I'm going to decrement counter. So if counter was 10. After I've decremented it, it's going to be 9. The F, what the F means is that you're going to take 10, you're going to subtract 1, and then the answer of 10 minus 1 is going to be saved back into the file. If you wanted it saved into working register, you'd put W that, but we want it saved back onto itself. Now, just in case you're wondering about the F and W, they are going to be defined in the include file, which I included earlier, which is much more convenient than, say, doing typing 0 or 1. And if you're wondering about what I'm talking about with the 0 and 1, let's have a look at the data sheet. So it's a bit-oriented operation. So let me have a look. Oh no, sorry, it's a byte-oriented file operation. So decrement the file and skip if 0. So decrement file and skip if 0 takes 2 operands, a file and D. Let's scroll on down, see if we can find it. Decrement file, skip if 0, so F has to be a value between 0 and 127 inclusive, and then D must belong to the set of 0 or 1. If it's 0, the result is placed back in the working register. If it's 1, then it's placed back in the file register. So you don't have to remember the 0 and 1 in the include file. 0 is going to be defined as W, and 1 is defined as F. So it just makes it convenient for us. If you didn't really understand any of that, just stick F on there if you want to just save it back in the file itself. Okay, so we've got 10, we then decremented it by 1, so that gives us 9. 9 is not 0, so it's not going to skip the next line. So then we execute the GOTO, which then is going to go to that label, and then the process repeats. It sends the pin high, sends the pin low, and then 9 minus 1 is going to be 8. Stores the 8 back in counter, which is going to be 1 0, I think we said. And then the process keeps on repeating until finally we have 1. So it's going to flip that output high, then low, and then it's going to decrement 1 by 1, so that gives us 0. And then of course 0 is 0, so then it's going to skip the next instruction, so it's going to skip that line, and it's going to return, and then carries on. Okay, so let's just watch that in action. So we are going to run the simulation. The green arrow shows that we're at that point now, so I'm going to press F7 to enter into the subroutine. And so let's just skip along here. So next thing, we're going to move the literal value 10 into the working file register. So the working register at the moment just happens to be 15. And then if I press F8 to jump over that, now the working register is 10, which is yep, there. So that's hexadecimal equivalent of A. And let's carry on then. Oh yeah, by the way, A was loaded, or 10 was loaded into the counter, which was 1 0. And then we're going to set port B RB4. So let's have a look at port B. Port B is currently all zeros, so now when I do F8, you'll now see that RB4 has been set. Next line, RB4 is cleared. And then the counter is currently A, which is deanery 10. So we're going to decrement it by 1, which gives us 9 there. You can see that's now 9. Hopefully you can see that anyway. And then so 9, it was not 0, so it didn't skip the next instruction. So the next instruction now to be executed is go to the label. So it goes back up to the label, and then it's going to pulse that again. So let's just keep on running through this, so you'll see it's going to go through. Now if you have a look at this here, keep an eye on that there, you'll see we'll be able to take it down to 3, 2, 1. Now so this time around, this is going to be the last iteration of the loop. So we've got 1 stored in the counter, so we're going to pulse the output high and low. And then the next command is going to decrement 1, which of course is going to then give us 0. That's going to be saved back into the counter. So now see we've got 0, and because the result of decrementing was 0, it skipped the next command, which was GOTO. So now it's jumped to return, and now exited the subroutine. So that pulsed the output 10 times. Hopefully that's clear, and that's going to be the end of the video then.